So today we're going to look at Math Course 1, Lesson 98. This is the sum of angle measures of triangles and quadrilaterals. All right, so what does this mean? The sum of interior angles of a triangle is 180 degrees. So if you were to take this angle and you were to transfer it over, let's say we cut it out and we flipped it upside down just like this, that angle would now be right here. See that? If we took this piece and we just chopped it off, flipped it over, that would be right there. If we took this corner of the triangle and did the same thing, and we just shoved it over here, we just cut it and then moved it over, that would be right in this position. And if we took this triangle corner and then flipped it all the way over here to that position, that would be the third triangle angle. And if you add up all three of those angles, they're always going to make a nice, neat 180 degrees. If you do the same thing with a quadrilateral, what's the difference between a triangle and a quadrilateral? Well, a quadrilateral has four sides. See, this has 1, 2, 3, 4. The triangle only has 3. And it also has 4 corners, and a triangle has 3 corners. So the sum of the interior angles of a quadrilateral, if we were to look at the interior angles of a quadrilateral like this one, plus this one, plus this one, plus this one, it adds up to 360 degrees all the way around. If we were to chop this one and just say flip it, put it right here, move this angle right here in this position, move this one over and flip it into that position, and this one this position, you see you got a nice neat circle. Here in the triangle you only ended up with 180 degrees. Well, with the square, if you do all 4 of the corners, you get a 360 degree. So that means you can tell, let's say for example we don't know what this corner's measure is, but we do know what this corner is, and we do know what the angle measure of this corner is. We can add those two pieces up. We know that those are 100 degrees, and we know that if we take 180 degrees minus that 100 degrees, you get the remaining corner, which is 80 degrees for this one. So we now know what that missing element was. You can do the same thing if you have a quadrilateral. We have one missing angle here. We don't know what it is. But we can tell, knowing that all 4 angles add up to 360 degrees, that means we can subtract the other 3 that we had, which would be 280 degrees taken away from that. So that'd be 360 degrees minus 280 degrees, and that would actually be 80 degrees. Let's look at a couple more examples here. If we extend a side of a polygon, so let's say that if we're looking at this, if we extend the side of a polygon, we can form an exterior angle. In this figure, angle 1 is an exterior angle. You can see angle 1 is an exterior angle, and angle 2 is an interior angle. What's the difference? Well, it's similar to yesterday's lesson where you had interior and exterior angles, and when you were looking at the transversals, this one is on the outside of this quadrilateral, and this one's on the inside. So external and internal. This would be the interior angle, and this would be an external angle. So keep that in mind. So external angle is that one, and then let me just use a different color here for our interior angles would be those. So exterior angles on the outside of that, interior angles on the inside. These angles are supplementary. What does that mean? That's a vocab word for math. that means that their sum equals something. What does it equal? The sum of those two measures equals a nice, neat 180 degrees. And if you guys look back at lesson 90, a full turn measures 360 degrees. So if Elizabeth, you know, if you're at the skate park, you know that if you're at the skate park, you know that you can actually do a 360 if you're really good. You can complete a 360. So if Elizabeth did a 360, that means that she's turning. She makes 3 turns to get around a park. And so if she's going to do that, she's going to make 3 turns around a park. She's turned a total of 360 degrees. So if she's facing one direction, but then she takes a nice sharp left and then another sharp left, and then she turns back this direction, she's still looking in the exact same position. So she essentially, when you add all 3 of those turns up, it's 360 degrees. Same thing as if she did a park that had 4 turns in it. All 4 of those total, if we were to add up angle 1 and angle 2 and angle 3 and angle 4, if we were to add up all those, it would end up being 360 degrees, the sum of all the measures. If she takes 3 turns to get around the park, then she is averaging 120 degrees per turn, because 360 divided by 3 is 120. You just know that you did a full 360, and if you do 3 turns, that means it's an average of 120 per turn. If she makes 4 turns to get around the park, then each turn averages 90 degrees, because 360 degrees divided by 4 equals the 90 degrees per turn. So just remember that these turns correspond to exterior angles of the polygon. So if you look at them, see, this is an exterior angle, exterior angle, exterior angle. These are all on the outside of the polygon. And anytime you have exterior angles of the polygon and that exterior interior angle combined, they're supplementary. What does supplementary mean? It means that they add up to 180 degrees. Since the exterior angle of a triangle was an average of 120 degrees, that means the interior angles must average 60 degrees, because 120 plus 60 equals 180 degrees. The triangle has 3 interior angles, so the sum of the interior angles is 180 degrees. Remember that. So if you have 3 times 60, that equals 180 degrees. So in this case, this would be an equilateral triangle. Each of those angles would be worth 60 degrees for each one. 60 here, this one would be 60, and this one would also be 60, and they're all degrees. The sum of the interior angles is 180 degrees. Since the exterior angles of a quadrilateral average 90 degrees, the interior angles must average 90. So the sum of the 4 interior angles of a quadrilateral is going to be 360 degrees. Each one of those would average 90. So this one would, if you were to add up all 4 of them and then divide by 4, you'd get 90 as the average. So this one could be greater than 90 or less than 90. It doesn't matter. In the end, if you add up all 4 and then divide by 4, you'll get the average. So again, the sum of the interior angles of a triangle is 180 degrees. If we were to add up all 4 of these, that would add up to 180 degrees, whatever this is. It doesn't matter. All 3 angles, interior, add up to 180. The interior angles of a quadrilateral are 360 degrees when added together. Let's try this one. So what is the measure of angle A in triangle ABC? Well, look at this. I already know what angle B is, and I know what angle C is. So because angle A is what we're looking for, and we know that if we add angle A plus angle B plus angle C, they're going to add up to 180 degrees. Since angles B and C are a total of 130 degrees, that means angle A is simply 50. 130 is taken away from 180. So if you have 180 minus 130, you end up with 150. So that would be angle A. Let's look at another example. What is the measure of angle T in this quadrilateral QRST? Well, it looks like we're given 3 of those angles already. This is a random quadrilateral, so it's not a regular. We don't get it's not going to be simple enough to say, oh, that it equals that and this equals that sort of thing. But I do know that they all have to add up to 360. So that just means I take the measures of Q, angle R, and angle S, you can see here, are 80, 80, and 110. They add up to 270. So because of that, I can just take that 360 degrees minus 270 degrees, and I'm left with, in this case, I'm going to borrow from that. This turns into 16. 16 minus 7 is 9. That'd be 90 degrees is what angle T equals. Okay. All right, let's try these. See if you can answer number 1 or letter A for me. What is the sum of the measure, of the measure of angle 1 plus the measure of angle 2 and the measure of angle 3? What is the sum of those 3? Angle 1, angle 2, and angle 3. The answer is 180 degrees. How did I know that? There was no measures here. It doesn't tell me, well, this is 100 degrees, or it doesn't give me any information here. How did I know that the sum of those 3 angles equals 180 degrees? I knew that because I'm looking at this idea here. The sum of the interior angles of a triangle are 180 degrees. That's always true. What is the sum of the measure of angle 4, the measure of angle 5, and the measure of angle 6? So measure of angle 4, the measure of angle 5, and the measure of angle 6. Trick question, guys. Should have known that one too. It's only 3 angles. It's a triangle. It's a trick question because, hey, you may have been fooled if you're looking at all 4 of those. But what is the answer to letter C then? What's the sum of the measures of the 4 interior angles of the quadrilateral? So now they're talking about these measures, like from here to here, from here to here, from here to here, and from here to here. What is the sum of the measures of the 4 interior angles of the quadrilateral? Boom. 360 degrees. Nice job, guys. All right, let's look at this one. What is the measure of angle P in angle PQR? Or sorry, triangle PQR. So if I've got the measure of angle R is 30 degrees, the measure of angle Q is 75 degrees. What is the measure of angle P? In order to find this, I need to subtract 180 degrees, and in this case, I see that 75 plus 30 makes 105 degrees. So I need to subtract that. And in this case, I would have 7. This would turn into 10. This would be 5 and 7. That means this measure right here is 75 degrees. So angle P equals 75 degrees. What about letter E? What is the measure of each interior angle of a regular quadrilateral? And it's regular. What does that mean? What does that even mean? If you answered 360 degrees, you were wrong. The answer is 360 degrees divided by 4 in a regular quadrilateral. The interior angles are all going to be 90 degrees. So good job if you answered 90 degrees. Letter F. If Elizabeth made 5 left turns as she ran around the park, draw a sketch that shows the turns in her run around the park and then find the average number of degrees in each turn. I'll give you guys the sketch. So let's say she starts out by going this direction. So here's the direction she's going. She takes a left turn. There's 1. And then let's say she makes another turn to the left. There's 2. And then she turns again to the left. There's 3. And then she turns again. There's 4. And then the 5th one is she's going back at her original direction. So what is so here's where she did her left turns here. You can see, and then she's going this way, and she's going this way, and then she's going this way, and then this way, and then finally she's back at her original position. What's the average number of degrees in each of those turns? Here's what you need to do. 360 degrees, right? So she's facing the same direction she originated, and that's going to be divided by however many turns she made, and she made 5 turns. So I need to do 360 divided by 5, and that would be 6. This would be 30. This would be 6. I'd go in there. Actually, I don't want to do it that far. Man, I just had a brain fart. Let me go back. 360 divided by 5. And in this case, you'd have 6, which would give me to 30. Subtract that, would be 6. Oh, I know what I'm doing wrong. I don't know why I was thinking that 6. But in this case, if it's going to be 360 divided by 5, 360 divided by 5 equals 7, which will give me the 35. Subtract that, bring that down, and then I'd have 2. So that means on average, she's going 72 degrees for each one of those. So each turn is an average of 72 degrees. All right, go ahead and give this a shot. So in this one, it says triangle FGH is an isosceles triangle. Angles G and H are both 65 degrees. So both of those are 65. What's the measure of angle F for this one? In this one, you're trying to find the measure of angle C, but actually, so let's see. This must be labeled wrong. So if angle A measures 90, this would be angle A. Angle B measures 50 degrees. And it doesn't matter really if they're labeled wrong. You still have the numbers, and the numbers are all you need to work with. So if you have angles A is 90, angle B is 50, what's the measure of angle C? And then number 3, what's the measure of angle K in JKLM? So we're looking for angle K here. And then what's the sum of the measures of the 4 interior angles of a square? All right, guys, that's it for today. Good luck with the quiz. Make sure you get everything done by midnight tonight, and we'll see you guys tomorrow. Have a good one.